Okay, we have 3 sub-sessions, each one with some concrete and practical examples in order to restore and protect the oceans. So let's start with the first one. I ask my guests to come into the stage. Daniele Borghi, innovation expert, Intesa Sanpaolo Innovation Center, and Ambra Cozzi, project manager, One Ocean Foundation. Welcome, please. Welcome, Ambra. So, we begin this panel by introducing this new report from the X-Plore series by Intesa Sanpaolo, right, Daniele, dedicated to the ocean and developed in collaboration with One Ocean Foundation. So, first question to you, Daniele. Why has Intesa Sanpaolo Innovation Center chosen this kind of initiative, like, you know, restoring and protecting the oceans?
Yeah, thanks for the question. Well, as Intesa Sanpaolo Innovation Center, we have a strong expertise on technology innovation applied to the industrial sector.
Yeah.
The idea behind the report was to build an excellent team with Fondazione Links, which are our historical partner in developing X-Plore reports, and with One Ocean Foundation, in order to reach goal to put in the same place both a comprehensive overview of which are the pressures that all the industries exert on the ocean. All industry, no one can say, I'm not involved. And on the other side, also a same-wise comprehensive analysis, a collection of all the technologies that already today are available in order to be adopted to relieve such pressures. So it's a very practical collection of use case, detailed analysis, of a list of references that everyone who works in specific domains can look for changing his way of work and decrease the impact of his activity on the ocean.
Clear. Ambra, what kind of focus does this report have?
Thank you, Mariangela, and thank you to the audience. I think I will call you the survivors of this full day. Actually, during this full day, we learned a lot about the role of the ocean for the stability of our planet. And this report is particularly interesting because it analyzed the role of the ocean in facing one of the main challenges of our time, which is the resilience of our food systems and the need for them to be regenerative. So if we delay the word sustainable, it means that the food system need to be regenerative. The ocean can be an important answer indeed. We heard a lot about blue food during this day. I'm not talking only about fish, but also about mollusks and seaweed, which are food with high level of proteins, but with a lower carbon footprint, or in general environmental footprint, if compared to land-based source of protein such as meat. So the ocean is an answer, but only if it is maintained in its good environmental status. Meaning that the pressure exerted by human activities on the marine ecosystem are prevented, mitigated, and remediated. For this reason, we decided to focus with this report on 3 main food-producing industries, which are agriculture, fishing, and aquaculture. Starting from agriculture, of course, agriculture operates on land. Nevertheless, it exerts a variety of indirect pressures on the ocean, which we explored in the framework of our research, Business for Social Sustainability, and then the project Ocean Disclosure Initiative, which my colleagues explained to you this morning.
Yeah.
So just to give you small tips on this pressure, I have a video. Grazie, regia. is behind my back while I'm talking, just to summarize which are some of the main pressure exerted by the agricultural operations. I would start with the emission of greenhouse gases because of change in land use. So deforestation, because there is need for more land to produce food. And then the extensive and excessive use of pesticides and fertilizers, which can end up in the ocean following the water cycle. And so I reconnect with this morning panel about water cycle and ocean pollution. The chemical substances in pesticides can alter the chemical integrity of water, generating pollution, while nitrogen-based fertilizers, if end up in the ocean through runoffs, can contribute to eutrophication. Prof. Carlos Duarte explained this process better than me. Eutrophication implies harmful algal blooms, creating dead zones, meaning zones with less oxygen or no oxygen, where marine life cannot survive. So that's important that innovations and new technologies are applied to agricultural sector in order to prevent and mitigate these pressures. Daniele can tell us.
Thank you. If we go back to the presentation, we will see a very synthetic list of which are the technologies that already today are available. Simply speaking, the goal is to prevent that the chemicals that are in excess reach the ocean. So there are two complementary ways to reach this goal. The first one is to treat the wastewater in order to recover chemicals like phosphorus or nitrogen, which are dissolved in the water. And this is beneficial not only for the ocean, but for the economy too. If you think that 90% of phosphorus that used in Europe is imported from abroad, 65% is used to make fertilizers. If we are able to reuse the same substances that are dissolved in the water, we save also a lot of money for our economy. The complementary approach is to reduce the amount of fertilizers that is needed. And there are a couple of targets. One are open field productions. There are two ways. One is to give only the amount which is really needed. So applying what is called precision farming or precision agriculture, which collect data from ground-based sensors, aerial-based sensors, and satellite information, both visible and hyperspectral imaging, is possible to define with precision which parts of my land need nutrients, which one needs more water, which one needs more pesticides. So there is a, let's say, chirurgical appliance of nutrients. And this is also beneficial for the farmer itself because it saves a lot of money. Yeah. As well as a soil test, because the soil has a different nutrition capacity which is embedded. So if the soil has enough nutrients which are needed from the plants, let's say, is useless to give more nutrients artificially, which are all wasted in the water. A complementary approach is to move to indoor farming. Indoor farming by itself save up to 90% both of water and fertilizers. And there are also some circular approaches in aquaponic farming too, where in the same tank, for example, coexist plants and fishes in a circular approach where the fishes feed from the plants, feed the roots of the plants, eat the root of the plants, but the ammonia which is produced by fishes as biological waste is transformed by bacteria in the nitrogen and nitrates and nitrates which are absorbed by plants. So I don't need to use chemical fertilizers because the fertilizer is produced by the fish itself.
Yeah, very, very interesting, I have to say. Do you think, Daniele, this covers about the innovations in the field of agriculture? These are some examples that you shared.
Yeah, absolutely. I made a cherry picking of most relevant, but of course, you will find in the report the whole spectrum of technology which are available and to adopt right now in agriculture sector.
Some examples, so, okay. Ambra, what about other two industries discussed in the report? They are like fishing and aquaculture.
Yes. So from agriculture, an industry which exerts indirect pressures on the ocean, we go back to fishing and aquaculture operating directly on the ocean. As mentioned, they can really represent an important answer for the challenge of the food system, which are under increasing pressure for population growth and climate change, but only if the pressure and the fishing, agriculture, aquaculture operation are conducted in a more sustainable, regenerative way. Also, in this case, I have a video behind me. Thank you, Regia. Which summarizes some of the pressures, direct pressures in this case, associated with fishing and aquaculture. So starting, of course, for fishing to overfishing and bycatch, so fishing of marine species which are not for commercial use, going to the damage to the seafloor caused by some techniques such as bottom trawling, mentioned before, so by my colleagues before. And then, of course, the plastic pollution coming from the abandoned nets, which are made of plastics, the famous ghost nets. These are some of the issues linked to fishing. Coming to aquaculture, concerns are linked to the introduction of an indigenous species because there are escapes from the cages if are well not done. Introduction of contaminants because we know that farmed fish sometimes need extensive use of antibiotics, for example, and then the use of too much wild small fish to be used as feed for the farmed fish, causing some alteration of the food webs and a loss in general of biodiversity. On the bright side, there are solutions, innovation and new technology applied by the companies, which we report in our report.
Yeah.
Exactly. Once again, for example, for ghost nets, biodegradable products, both for nets but also for the cordage which is used in the cages for offshore aquaculture. We can also avoid, for example, by catching using advanced technologies like hydroacoustic technologies or underwater LED lighting, which is changing in color, in frequency, and in intermittency of light in order to attract or repel the fishes that we don't want. Same as there are AI algorithms that are applied to image analysis so that we can, there are some nets which have onboard cameras which identify fish by fish that enter in the nets, and according to if they are wanted or not, there is like, let's say, a valve, a switch that, okay, I want you go in the net, you don't want it, you go safe in the ocean. Mm-hmm. And the same image analysis technologies can be used in aquaculture to, for example, to detect the stress level of fishes, because it's possible to recognize the behavior of fishes if there are problems, for example, with dissolved oxygen or other parameters which are in real time analyzed by underwater sensors. Just to give you a short overview. Okay, we could talk about offshore farming with dedicated cages, but also new innovation like cellular agriculture, because also for fish, there are some startups, commercial companies, which are cultivating the fish in lab, which is complementary to fishing and aquaculture, to give a concrete answer to the increasing demand of food from the worldwide population.
This is really, really interesting. And if you, of course, want to read more about the report, exactly, right, they can, which is the best way to read this report.
Yeah, it's published online. Maybe we have a QR code from...
Yeah, maybe we can see the QR code.
And both on Intesa website, also One Ocean Foundation website will be published soon. So please read it. I promise it's very interesting.
Yeah, it's very interesting, and of course, if you are here, you call them. How did you call them before?
Survivor.
The survivors. If you are survivals, maybe you are interested in this report,
I hope
right?
so, yeah.
Okay, thank you, Ambra, thank you, Daniele,
Thank you very much.
really so much.
Thank you.
So I'm going to subsession 2. Thank you. Okay, and furthermore, serving as concrete examples of what people are doing in order to protect the oceans, and adding to what Daniele and Ambra have just said, we are delighted to introduce some representatives from 2 companies. Well, they have developed practical, innovative solutions in various sectors to reduce pressure on the oceans. So, first, I introduce Claudio Torre, Chief Financial Officer, WSense. Please, Claudio. Thank you so much for being here. Hi. So,
Thanks for hosting us.
thank you. WSense is a deep tech company, right? So my question is, what kind of innovation do you, and if you can explain to us, what do you do?
Absolutely. Yes, we are a deep tech company because we did a lot of R&D, and at the end we invented the Wi-Fi of the underwater.
Ah, okay.
So you can wonder, okay, what do you do with the Wi-Fi underwater, right?
Yes. What do you do?
So basically, in order to protect and restore our ocean, you need to measure. So you need to understand what the current situation is, what the kind of impact your solution or your action are having in the water, and this is where we come. So we basically connect people, we connect sensors, we connect machines. So you can have information real time coming from the water. Right now we work up to 3,000 meters below the water, which means that we can collect information real time, which you can use to avoid, for instance, to go to the site, or understanding whether your actions are improving the quality of water, for instance, or you can use an electric drone to go and inspect a specific case, or we all have a surveillance system at our house, so maybe you want to spot who is dumping dirty water into our ocean. Well, with our technology, you can do this easily, and you can do it now at scale.
So, you are seeing concrete results, right? It's working, and you see a potential from these technologies. And looking at the future, what can you achieve based on what you do?
Yeah, I was talking to a scientist, I'm not going to mention the name,
Okay.
and he's doing a lot of studies on the impact of the ocean on our planet Earth.
Mm-hmm.
And so I was asking the scientist, okay, which kind of data are you using? Yeah, I'm using some data that I found, which are very scattered. And I talked about this real-time technology, so then he can start actually collecting and building time series to predict the future phenomena as well. And the answer was, yeah, okay, but I need historical data. So I said, okay, if you start now, every second that you're wasting not using our technology is a data that you are not collecting, which means that you're not going to have the knowledge to basically act and improve our planet. So in the future, our technology is scalable by definition because we work in any water. So now we are working a lot in of course, Europe, including Norway. We expanded in the Middle East. And of course, in the future, we see really any part of the ocean that needs connectivity. I mean, right now, the ocean is 70% of the planet. So all the water in the surface is 70%. And the wireless connectivity, the wireless coverage is close to 0%. So we have a lot to do.
I mean, there is a lot of potential
A lot. If you look at the telecommunication sector, in the last 35 years, yes, there is a lot to do.
Yes, because usually we talk about collecting data, etc., but we don't talk about connecting all this data together. And via Wi-Fi actually is one could think it's a natural idea, but of course you did it. So I read also you are a spin-off of La Sapienza University, is that correct?
Yeah, our CEO is a professor of Sapienza University.
Because I think this fact, universities, it's a very US model, university and companies growing together. And, you are the example that can be a success.
Yeah, we are trying to get there.
Yeah,
Yes.
and good luck with everything. And thank you so much for being with us
Thank
today.
you.
Thank you.
Thank you, everyone.
Thank you. And this is the first case. Second one is test one, and I introduce Alessandro Taini, CEO, test one. Please, Alessandro, come up to the stage. Hi, nice to meet you. So we are talking about
Meet you. Good afternoon.
patented technology, right? Test one. You are working in Europe, but as well in the United States, I read, and you allow to clean of oceans from hydrocarbon spills. Tell us more.
Thank you very much. Yes, first of all, I would like to come back to 2010,
Okay.
Gulf of Mexico disaster. We all know this disaster. We had hundreds of oil in the ocean. We had 69,000 people working in the accident. We had a spend of $1 billion to recover the oil. The result has been that we were able to recover the 3% of the oil. So it's clear that we have a problem. Otherwise, it's easy to think that this has been a disaster, but is a unique case in our history. And this is not real, because the same amount of the Gulf of Mexico of oil spilled is the same amount of oil that we spill on average every year only in the Mediterranean Sea. And the percentage of recovery of this oil, there is an important research on the Marine Pollution Bulletin, from 1969 to 2010 has been 2.3%. This is the average of what we can do. And the other big problem is that just 1 liter of oil is able to pollute up to 1 million liters of water. And so it is clear that this is a problem. And our mission is trying to assess the problem and to solve the problem.
Wow. Okay. And as I asked before to Claudio, do you think watching daily what you have accomplished that is giving results, practical results? Are you satisfied with that?
Yes, absolutely. As you have seen in the video, I kindly ask you to the regia, if it's possible,
let's
rest
watch
in
the
the video,
video.
just to briefly explain the technology. It's very simple. It's a sponge, is patented, because the characteristics are that is able to absorb the oil, every kind of oil, and not the water, so it's selective. You can see that just in a very fast way, in just one passage, it takes the oil inside. This is an experiment with more oil. Then it's possible to squeeze the sponge, have back the oil, which is reusable, is pure, and we can reuse the product, the polymer, for 100 times. So 1 kilogram of the sponge is able to absorb 6 tons of oil. We addressed the real disasters, for example, in Spain, a tier 3 emergency, so an international emergency, with very good results. In fact, the solution has been also published in different several scientific journals, because we achieve the 60% of the oil recovery.
This oil can be used, for whatever reason, right? Like we use the oil today.
Yes, exactly. We can re-put the oil in a refinery process and have back the value of this oil that is pure. without
because,
the
you know, one can think also from a geopolitical perspectives with all the things that are happening in this moment. This could be really a great solution also for using oil without, letting the oil spread into the ocean.
Yes, absolutely.
Which is a double result.
Yes, it's a double result, and then we have
Yeah.
to consider that in a war scenario, the infrastructure with the oil are on high danger because they are strategic. So it's very easily that we will have an oil spill.
Can I just ask you briefly about the possible developments of this company of yours?
Yes, the first one is the development in the market, because actually we are using absorbents that are mono-use, are made by plastic. They break in the water, so we can lose pieces of plastic and oil in the water. So we are trying to change this perspective, also to reduce the number of waste, because we demonstrated that we can also reduce the CO2 by 99%, compared to traditional methods. And then we are developing other solutions with engineered systems that we tested in the United States with BP and US government last year, the prototype. And we are also creating satellite projects to assess the oil spill and to intervene with drones in the oil spill cleanup.
Okay, so I thank you so much, Alessandro.
Thank you very much.
For being with us today. Thank you for explaining so well. Thank you. Ciao. Okay, so the sub-session number 3, we have a special guest. So it's my pleasure to introduce Princess Nina of Greece. Hi, nice meeting you in person. Hi, Nina.
Hello, how are you?
Okay, my last interview for the survivals of the afternoon.
Thank you for having me.
Yeah, and you are here with us because you in 2017 established a very important center, a Bazaruto Center for Scientific Studies, which, it goes by BCSS, so BCSS, which is the first no-profit research station in order to collect data to protect the oceans. Can you tell us a little bit more?
Of course. So I started BCSS in 2017.
Yeah.
On the back of having spent many years traveling in Africa and mostly terrestrial Africa. And I noticed that an immense amount of resources, aid, charitable work, tourism was going towards Central African terrestrial efforts. And when I spent time in Mozambique and I communicated and I observed the coastal communities, I understood that there were equally big efforts that needed to take place within the coastal communities and the coastal ecosystem. This led me to the realization that I wanted to set up a non-profit marine research facility which could not only collect data globally, but also welcome volunteers, students, professionals, and academics from all around the world. You'll see some pictures behind. And this was really to help safeguard these coastal communities that we were interacting with, but also to help obtain data which up until that day was not existent in the region that we are in, which is the Bazaruto archipelago in Mozambique. And what's that really culminated to today is that we're the first permanent ocean observatory on the Eastern African coastline. We are a platform that not only collects data, but also gathers data and publishes it for free, globally.
Oh, wow.
To anyone who applies.
So you have a website?
We do, and you can apply and then you can obtain our data. And I'd like to share how all of that is possible because it's through a research model that we developed and a business model that we call Resort to Research. Mm-hmm. And Resort to Research is a way that we fund this in an ongoing, regenerative, not sustainable manner. On the same island where the research facility is, we also have a 5-star hotel.
Yeah, I read
Kisawa Sanctuary.
Kisawa, okay.
And this hotel, of course, welcomes tourists all year round. And a portion of the revenue annually goes to PCSS in order to fund the long-term, permanent research opportunity for our team of scientists. And in our very humble way, this has been our interpretation of how to operate and hopefully thrive in a blue economy, in a regenerative tourism component.
So it's like two parts of a strategy. The hotel, I think it's also an idea to change the way we think about tourism, and the center, which is so important.
We say the more happy guests, the more research we can commit to.
Yeah, interesting idea. And what about the cooperation with the industry? How your organization, for example, and industry can best work to obtain the best outcomes?
Thank you. I think that's a very important question because I come from a non-professional academic background. I really started this from a place of passion. And of course, data through research is information, information is knowledge. However, in my humble opinion, I think it needs both the academic environment as well as the passionate general public, the volunteers who we welcome, in order to collaborate, because it's only through this collaboration that we can generate a larger accountability for what we were talking about all of today. And I think additionally to that, it's very, very important that the barriers to entry continue to be lowered, that it is increasingly easier for people to come into this industry, whether it's through preservation, conservation, research, many of the things that we heard today, but I think it is still very difficult to come into this industry, and I think if we can collectively look at ways to make this easier, I think we can generate more passion. Of course, we're doing this with the local Mozambicans through training opportunities, development opportunities. However, I'd like to call out an example today because there's a wonderful person that I met under the name of Becky, who's here today, and she's a wonderful example of someone who comes from an investment banking background. She came to be a volunteer at BCSS in the hopes of possibly considering a career change, and I, from meeting her today and her coming here today, I understood that she became so enamored, so passionate about the oceanscape that I believe she's here today to look at opportunities how to develop her career in this sector. And I would just like to mention that because I think that is what we're all about. And we're here to inspire and create passion in order to fulfill our respective goals within our respective lines of duty.
Yeah, I agree with you. I think that not only younger generations, but talking, communicate these problems more. We can have also not only younger generation to have changes of their life, for example. So it's very important to talk about these things. I sense that some change has been going on, so I hope there will be also more in the future. My last question to you is, Nina, what are your plans for the next futures?
Thank you. It's a nice question. I personally think that before I look forward, I have to look back. And in 2023, BCSS completed a number of exciting things. We collected 1.3 tons worth of plastic debris from the ocean. We welcomed 100 volunteers. We certified 60 divers. We helped support, complete, and achieve a number of PhD, master, and bachelor degrees by students coming to complete their research work locally with us. But most notably, we spent 1,000 hours offshore locating, 3D mapping, and documenting 13 new coral and rocky reefs, which had never been documented before. And again, this data, this information through our facility is freely available. So when I look at what's been achieved in 1 year, and I then cast my eye forward, I see every possible reason for more research facilities of this capacity, which combines volunteers from the general public, of course, serious scientists at the other end of the extreme, in many different ecosystems, not only the oceans, it could be alpine territories, it could be desertscapes, it could be jungles. And if these research facilities collectively communicate through an interconnected network, and I extrapolate what BCSS has achieved in 1 year, and I look at multiple facilities over multiple years, I personally feel very excited and full of hope.
Oh yeah, I am also full of hope. So I hope that what you said will be true. So thank you so much for being with us today. Thank you.